Okay, we have already talked about rounding and inequalities, but moving into chapter 10, we'll be doing a little bit more rounding of our uh, of certain probabilities that we'll call p-values. And we'll be comparing those p-values to a level of significance and trying to determine if our p-value is less than a particular level of significance. And so I thought it would be worthwhile to review a little bit about how rounding works so that we can round our p-values correctly, and then review how to compare decimal numbers so that we can make the appropriate comparison of our p-value to the level of significance. So, as a reminder, the way that you round a decimal, if you want to round to, let's say, 3 decimal places, then you look at the fourth digit that comes after the decimal. And if that digit is 4 or less, then you keep the third decimal place the same and you drop all the remaining decimal places. If that digit is a 5 or more, then you increase the third digit by 1 and drop all the rest of the numbers that follow it. So we'll look at a few examples. Here on example 1, we're asked to round to 3 decimal places, and we have this first number, 3.1415925, which may be familiar to some of you, right? That's the number pi, approximately. So if we wanted to round this to 3 decimal places, we would look at the fourth digit that comes after the decimal. 1, 2, 3, 4. That's this number right here. Okay? And it's a 5 or more. And so that means we need to take our third decimal place here and go up 1. So we would call this 3.142, and we would drop all of the remaining digits. Okay, so this is approximately 3.142. Okay. Looking at something like part D, we have 253.545454. If we wanted to round this to 3 decimal places, right, the third decimal place is this one right here. So we look at the decimal place that comes after it, the fourth one. It's a 4 or less. So we're going to leave the 5 the same and just drop those digits. And we were going to say this is approximately 253.545. So I will let you pause the video and work out the rest of those examples, parts B, C, and E in example 1, and then I'll work out my solutions. Okay, so I'm going to give you my solutions now. For part B, I want to round to 3 decimal places. 9 means that the 7 needs to go up, so I'm going to call this 0.258. For part C, the third decimal place is this 4, so I look at the decimal that comes after it. It's a 5 or more, so this 4 needs to go up to a 5. This would be about 253.455. And finally, for part E, 1, 2, 3 is this 6. The 9 that comes after it indicates that the 6 should go up to a 7. So this would be about 0.097. Okay, and that's how rounding works. The same thing would be true if we wanted to round to 4 decimal places. So if I want to round to 4 decimal places, then to make my decision about whether to round up or to leave the number the same, I look at the 5th decimal place. So in the case, so we have the same list of numbers here. If I wanted to round this first one to 4 decimal places, I would go 1, 2, 3, 4. That's this 5. I look at the digit that comes after it, right? It's a 5 or more, right? It's a 9. So that means this 5 needs to be rounded up to a 6. And I would call this 3.1416. Okay, so once again, I'll let you pause the video and work out the rest of them. Okay, so I'm going to give you my solutions now. So this one to 4 decimal places, This 8 indicates that the 9 needs to go up. And that's a little bit tricky because 9 has nowhere to go. So one way that you can think about this is to think of it as a 79 and to say that the 79 needs to go up to 80. We would say this is approximately 0.2580, okay, to 4 decimal places. For part C, 1, 2, 3, 4, after that digit is a 4, so I'm just going to drop them and leave that digit the same. This is about 253.4545. For part D, 1, 2, 3, 4, I look at the digit that comes after, it's a 5, so this 4 needs to go up. Okay, so this would be 253.5455. And then finally part E, 1, 2, 3, 4. The digit that comes after this is a 2, so I'm just going to drop those digits, and this is going to be 0.0969. Okay, so this is how rounding works. Once we have rounded our p-value to the appropriate number of decimal places, most of the time we'll round it to 4 decimal places, then we'll need to compare that p-value to the appropriate level of significance, which will usually be 0.05 or 0.10 or 0.01. So just as a reminder, when you're making these comparisons, if you have a hard time doing this, my advice would be to take whichever number that has the fewer number of decimal places and just add zeros to the end of it until the two numbers you're trying to compare have the same number of decimal places. If you do that, then it'll become really obvious which number is bigger than the other. So if we're looking at part A, for example, and you're comparing 0.2 to 0.05, some of you struggle with this because you think, well, 2 is less than 5, and so you would want to put a less than sign in here. But that would be incorrect because this number here has 2 decimal places, and this number only has 1 decimal place. So what I need to do is add a 0 to this number so that now both numbers have 2 decimal places. Okay? And if I do that, then I can see really clearly that I'm not actually comparing 2 and 5, I'm really comparing 20 and 5. And 20 is bigger than 5, so this should have a greater than sign. Another thing that trips students up is the way that these symbols look. And the last time we reviewed this, I tried to make it really clear that actually the symbols shouldn't be confusing. They look exactly like what they mean. The bigger part of the symbol is opening up towards the 20 because the 20 is the bigger number. And the smaller part of the symbol is pointing towards 5 because 5 is the smaller number. So that should be pretty straightforward, actually. And you can read these statements left to right, or you can read them right to left. If we read left to right, this would say 0.2 is greater than 0.05. And if we wanted to read it right to left, we would say 0.05 is less than 0.2. Those two statements mean exactly the same thing. So just to give you a couple more examples, in part B we're comparing 0.02 to 0.05. Notice that both of these numbers already have the same number of decimal places. They both have 2 decimal places. So I don't need to add zeros to either of the numbers, right? I'm basically comparing 2 and 5, and 2 is less than 5. So that one would have a less than sign. For part C, I'm comparing 0.0201 to 0.05. Now, this number has 4 decimal places, so here, and this number only has 2, so I'm going to add 2 zeros to this one so that I can make the comparison. So now it becomes pretty clear that what I'm really comparing is 201 to 500. Well, 201 is less than 500, so I should have a less than sign there. Looking at part D, on the other hand, I have 0.201 compared to 0.05. Here I have 3 digits. Here I only have 2. So I'm going to add a 0. And now it becomes clear that I'm comparing 201 to 50. Well, 201 is bigger than 50, right? So the inequality should go that way. Eventually, you'll get to the point where you can make these comparisons without having to add the zeros, right? And you can just do it quickly and efficiently, and that's great if you can do that. If you can't do that, that's also fine. Just continue to add the zeros if you need to. Looking at part E, for example, the inequality should go this way. 0.2001 is greater than 0.05. So I'm going to let you go ahead and pause the video at this point and finish out the remaining two columns. Okay, so go ahead and give the video a pause, and then I'll check back in and give my solutions. Okay, so I'm going to give you my solutions now. For part F, these two numbers would be exactly the same. They're equal. You can see that, here you have 4 digits, here you just have 2. If I add a couple zeros, oh, well, it's just 1,000, right? 1,000 equals 1,000. Okay, so for part G, this 15 is bigger than 10. For part H, 0.01 is less than 0.10. For I, 0.0193 is less than 0.10. And for part J, 0.0087 is less than 0.10. If you struggled with any of those, remember to just add the zeros. So for part I, for example, here I have 4 digits and here I just have 2. So I need to add 2 digits here, 2 zeros. And now it becomes clear that I'm just comparing 193 to 1,000. Well, 193 is less than 1,000. Okay? And you can approach all of the problems that way. So looking at the third column, we should have a greater than, a less than. These are equal, and this is less than. Okay, so same thing, add the zeros if you need to in order to help that make sense to you. But that's it for our little review here. You'll have a My Lab assignment attached to this to help you practice a little bit more. And hopefully that'll help you get through chapter 10 and beyond, right? So that should be all of the math content that we need to finish out the stats course.